Welcome back. This is where things get interesting. For the past 8 parts, you've been typing prompts into a terminal, but the Ollama service has quietly been running a full REST API the entire time. It's sitting on localhost port 11434, no authentication, no API keys, just waiting for you to send it some JSON. Today, we stop being users and start being developers. So why bother with the API when the CLI works fine? 4 reasons. First, programmatic control. You can fire off 1,000 prompts in a loop and process every response, something you'll never do by hand. Second, it's language agnostic. Python, Go, Rust, or just Bash and curl, anything that speaks HTTP speaks Ollama. Third, streaming. Tokens arrive as they're generated, which is what makes UIs feel responsive. And fourth, this is the foundation for the rest of the series. Open Web UI, RAG, Ask My Docs, parts 13 through 22. All hit this same endpoint, learn it once here, and everything that comes later gets easier. Ollama actually exposes around 10 endpoints, but honestly, 4 of them carry the entire workload. Generate is your stateless single shot, fire a prompt, get a completion, done. Chat keeps a conversation going, as long as you send the full message history back each time. Embeddings turns text into vectors, which is the foundation for RAG starting in part 11. And tags is the quick get that lists what models you've actually got installed. Master these 4, and you can ignore the rest until you genuinely need them. So before we touch any code, let's prove the API works with the most boring tool possible, curl. Post some JSON to localhost. 434 APIs you generate. Name your model, drop in a prompt, and set stream to false so you get one clean response object instead of a flood of tokens. What comes back is exactly what you'd expect. The model name, the response text, and a done flag. That's the whole contract. Every client library you'll ever use is just wrapping this. Now drop that stream false flag and you get the real default behavior. One JSON object per token streamed back as they're generated. Each chunk carries a piece of the response and a done flag set to false until the very last one flips done to true and hands you the timing stats. Your job as the client is simple. Concatenate the response fields as they arrive and stop when done goes true. That's exactly how every chat UI feels like it's typing at you in real time. Now let's move from curl into actual code. In Python, you don't need an SDK or any wrapper library, just requests. Post to localhost, or neo, where's ne. 434 API generate, handed a model and a prompt, set stream to false so you get one clean JSON back and pull the response field out. That's the whole pattern, about 10 lines, and you've got a working AS function you can drop into any script. Flip stream to true and the shape of your code changes a little. Instead of one response, you iterate over the lines as they arrive, each one a small JSON chunk with a piece of the answer. Decode it, print the response field with flush enabled, and you get that same token-by-token feel as the CLI chat right inside your own program. The timeout of 300 seconds is just insurance for longer generations on slower hardware. Generate is great for one-shot prompts, but real applications need memory. That's where Docker API chat comes in. You send the entire conversation as a list of messages, system, user, assistant, user again, and the model sees the full context. If you've used the OpenAI SDK, this shape will look immediately familiar, which means porting existing code over is mostly a matter of swapping the base URL. Now, back in part 7, we baked parameters into a model file, but you don't always want to rebuild a model just to nudge the temperature. Drop an options block into your JSON body and you override those defaults for a single call. Temperature for creativity, numPredict to cap the response length, top P for sampling, and seed when you need reproducible output for tests. Same knobs as the model file, just per request. Speaking of useful knobs, here's one that'll save you hours of regex misery. Set format to JSON and the model is constrained to return valid parsable JSON. No more coaxing it with please respond in JSON and praying. Feed it unstructured text, ask for the fields you want, and pipe the response straight into JSON.loads. That's a working data extraction pipeline in about 10 lines of code. Now, up to this point, everything's been on localhost, which is the safe default. But eventually, you'll want to hit Ollama from another machine, your laptop talking to a beefy GPU box in the closet, say. Edit the systemd unit, set Ollama host to 0.0.0.0 or 11434, restart, and you're listening on the LAN. One serious caveat, though, Ollama ships with 0 authentication. Anyone who can reach that port can use your models and read your prompts. Put it behind a firewall, a VPN, or a reverse proxy with auth. Never, ever expose it raw to the public internet. All right, before you go off and build something, let me save you an afternoon of debugging. Connection refused on 11434, the service isn't running. Start it. 404 on a model, you haven't pulled it yet. Empty streaming response usually means you forgot to iterate ITER lines and accumulate the chunks. Timeouts on first load are normal, bump it to 300 seconds or more for big models. And if JSON parsing blows up midstream, remember, each line is its own object, not one giant blob. Parse line by line. With the rough edges out of the way, here are 6 projects small enough to finish tonight, 30 to 50 lines each. Pipe your logs into a daily summary email, hand a messy CSV to JSON mode and get clean structured output back. Turn a git diff into a proper conventional commit message. Tag your inbox by urgency, translate shell commands between Hungarian and English, or add docstrings to a Python file in place. Pick one, build it, and you've got a real local AI tool by morning. Before you start building, let these 5 points settle. Port 114034 has been quietly serving HTTP and JSON since Part 5. No SDK, no auth, any language you like. 4 endpoints, generate, chat, embeddings, and tags, will carry you through almost everything. Streaming is the default. Flip it off when batch is easier. JSON mode turns messy text into parsable data, and one warning worth repeating. Never put Ollama on the open internet without putting auth in front of it. And here's the page worth bookmarking. 12 items cover roughly 90% of what you'll write against Ollama, the 4 endpoints on the left, the JSON fields you'll set on every call, and 2 operational knobs, Ollama host when you want LAN access, and a generous timeout because cold model loads are slower than HTTP usually expects. Print it, pin it, and you'll rarely need to dig through docs mid-build. And that brings us to part 10, where we put the API to work. Answering a question every local AI developer eventually asks, how fast is my hardware really? We'll write an actual benchmark script, tokens per second cold start latency CPU versus GPU, using the same endpoints you just learned. 9 down, 15 to go. See you in the next one.